The next thing that we're going to look at is what we call the location principle. What the location principle says that is if it's a polynomial function, f, and a and b are two real numbers such that f of a is less than 0 and f of b is greater than 0, then I know that f has at least one real 0 between a and b. So what that really is saying is that if I have a and b are two x's, and if I plug the x into your function f, if the answer when I plug in a is a negative number, is a 0, and the answer when I plug in b is a positive number, when it's greater than 0, then I know that in between a and b, x equals to a and x equals to b, there is a 0 there, which makes sense, right? Because if you think about it, if this is a, and this is b, and I say a is less than 0, so there's a point right there, and b is greater than 0. In order for the line to connect between a and b, there has to be a 0, a solution, or x-intercept in between, because it went from a positive number to a negative number. So let's take a look. Find all the real zeros of this function f of x. Now, I'm going to complete this table. This might not be the most efficient way, but just hang with me. I'm going to complete this table, and then I'm going to try and see guess where my zeros must be located. So when x equals to negative 3, plugging that in, we have 6 to the third power. Let me use my handy dandy calculator real quick. We have 6 to the third power. 6x to the third power, sorry, plus 5x squared minus 17x minus 6. Okay, when I plug in a negative 3, I am going to get negative 72. And I keep going. When I plug in a negative 2, I'm going to get 0. When I plug in a negative 1, I'm going to get 10. When I plug in 0, I'm going to get negative 6. When I plug in a 1, I'm going to get negative 12. When I plug in a 2, I'm going to get 28. When I plug in a 3, I'm going to get 150. Okay, so now that I have completed the table, right, I plug in these numbers, figure out what it is. Now I want to see where are my zeros. First of all, a 0 is on your x-axis. That's your x-intercept. So that means y must be 0. So first thing first, I can already tell that negative 2 comma 0, this is going to be my 0 right there. Now, if I'm looking at this, right, I can do a quick sketch of the graph if it needs to help me. At negative 3, 2, 1, 2, 3, 1, 2, 3. At negative 3, it's all the way down at negative 72. At negative 2 is a 0. At negative 1, it's a 10. So obviously, it's going to come up and cross the x-axis there. But what happens after that? At 0, it's going to be at negative 6. So between negative 1 and 0, the graph has to somehow curve back down. So there has to be a 0 somewhere in between negative 1 and 0. Because if you look at your y value, it went from a positive to a negative. So somewhere in between 0 and negative 1. That's going to be another 0 right there. And if I keep looking, between 1 and 2, the y value went from a negative to a positive. So there has to be another 0 in between there. It looks like there's 3 zeros. And if you look at the equation, the highest exponent, the degree of this polynomial, is 3. So it looks like I found all my zeros. Now, I can definitely graph this on my calculator and actually use the 0 function of your calculator to find the exact 0 on the graph. So if here's my graph. Let's make sure that you're not getting the glare. I'm going to go to my current graph because that's what I used. All right, I'm going to go to Zoom. And go ahead and go to Zoom Windows setting, because I know according to this, my zeros are going to be at -2, somewhere between 0 and -1, and somewhere between 1 and 2. On my Windows setting, on the X minimum, I can just put -3 as my X minimum. X maximum could be a +3. Y value, since I already got the Y value here, the lowest Y value looks like it's a -72, so let's put -75. The highest looks like it's 150. So there is my graph right there, and definitely find 3 zeros. One right there, one right there, and one right there. Using the menu function, the analyze graph, go to zeros. Zeros is number 1. I'm going to highlight the left-hand side of the 0 and the right-hand side. So that one has a 0 at -2, 0. Keep going, analyze graph, go to 0, highlight the other 0. That one has a 0 at -0.333, 0. And the last one, analyze graph, zeros, highlight that last 0 right there. The last one is at 1.5. So let's write those zeros down. At -2, -0.333, and 1.5. X equals to -2, x equals to -0.333, x equals to 1.5. And if we compare -2, absolutely. X equals a -0.333, that is definitely between 0 and -1. And x equals a 1.5, that is definitely between 1 and 2. That's how I can estimate using the location principle where the zeros are, and then using the graph to find the exact zeros.